Python 3 control structures, Booleans and comparisons. Oh, I have to go back some more. Another type in Python is the Boolean type. There are two Boolean values, true and false. They can be created by comparing values, for instance, by using the equal operator. So in the first insertion, we have my underscore Boolean equals true. And the next insertion, you just have my underscore Boolean, and when you hit enter, you get the output of true. The next insertion, you have 2 equals 3. Well, here you're using the double equal symbol, which when you hit enter, your output will be false. And in the very last insertion, you have the string hello, double equals the string hello. And in that instance, you hit enter and you will get the output of true. Be careful not to confuse assignment, which is one equals symbol, with comparison, which is the double equal sign. What are the two Boolean values in Python? True and false. Another comparison operator, the not equal operator, which is represented by the exclamation and a single equals symbol. This evaluates to true if the items being compared aren't equal, and false if they are. So at the first insertion point, we have 1 not equal 1. That evaluates to false. And at the next insertion, we have the string 11 not equal the string 7, which will evaluate to true. And lastly, we have 2 not equal 10. That evaluates to true. What is the output of this code? 7 not equal 8. That's a true statement. Python also has operators that determine whether one number, float, or integer is greater than or smaller than another. These operators are greater than and less than, respectively. So at the first insertion point, we have 7 greater than 5. This evaluates to true. And at the second insertion point, we have 10 less than 10, which evaluates to false. What is the output of this code? 7 greater than 7.0. Well, that's false. The greater than or equal to and smaller than or equal to operators are shown with the following symbols: greater than, equal, and less than, equal. They are the same as the strict greater than and smaller than operators, except that they return true when comparing equal numbers as well. So at the first insertion, we have 7 less than or equal to 8. This evaluates to true. And in the next insertion, we have 9 greater than or equal to 9.0. This also evaluates to true. Greater than and smaller than operators can also be used to compare strings lexicographically, which is the alphabetical order of words, and it's based on the alphabetical order of their component letters. What is the output of this code? 8.7 is less than or equal to 8.70. This will be true. If statements. You can use if statements to run code if a certain condition holds. If an expression evaluates to true, some statements are carried out. Otherwise, they aren't carried out. An if statement looks like this: if, expression, colon, next line, statements. Python uses indentation, white space at the beginning of a line, to delimit blocks of code. Other languages, such as C, use curly braces to accomplish this, but in Python, indentation is mandatory. Programs will not work without it. As you can see, the statements in the if should be indented. What part of an if statement should be indented? The statements within it. Here is an example if statement. If 10 is greater than 5, colon, drop down a line and indent, print, parentheses, and double quotes the string 10 greater than 5. Then you go down another line or two and remove your indent, so you're putting the next statement all the way to the left, print the string, program ended. The expression determines whether 10 is greater than 5. Since it is, the indented statement runs, and 10 greater than 5 is output. Then the unindented statement, which is not part of the if statement, is run, and program ended is displayed. So here's the result. You see 10 greater than 5, and then the line underneath it, program ended. Notice the colon at the end of the expression in the if statement. So let's go back up. If 10 greater than 5, colon. So that's what it wants you to notice. As the program contains multiple lines of code, you should create it as a separate file and run it. What is the output of this code? Spam equals 7. If spam is greater than 5, colon, print the string 5. If spam is greater than 8, colon, print the string 8. Well, spam is set to a value of 7, so it's going to print 5. To perform more complex checks, if statements can be nested one inside the other. This means that the inner if statement is the statement part of the outer one. This is one way to see whether multiple conditions are satisfied. For example, num equals 12. If num is greater than 5, print the string bigger than 5. If num is less than or equal to 47, colon, print the string between 5 and 47. Result. Bigger than 5 outputs, and on the following line, between 5 and 47 also outputs. What is the output of this code? Num equals 7. If num is greater than 3, print 3. If num is less than 5, print 5. If num is equal to 7, print 7. So we are definitely going to print 3. And it's not less than 5. And it is equal to 7. So 3, 7. 3, 7. It's not even letting me do 2. All right. Num is equal to 7. If num is greater than 3, print 3. If num is less than 5, no. If num is equal to 7, print 7. Okay, I'll put 7 then. What am I doing wrong? Let's see. This must have to do with the indentations. We start off with num being set equal to 7. If num is greater than 3, you will print 3. If num is less than 5, I don't understand why I'm not printing 7 and 5. I'm going to guess that if num is less than 5, the two indented statements, print 5 and if num equals 7, belong to the if condition if num is less than 5. With that being said, if that internal if statement, if num equals 7, if that belongs to the if num is less than 5, then it should not print because it's asking first if num is less than 5. That's not true, so everything that belongs to that particular if condition should be ignored. So with that being said, I'm going to guess that the only thing that outputs is a 3. Let me see if my logic is correct there. Okay. Alrighty. Else statements. An else statement follows an if statement, and contains code that is called when the if statement evaluates to false. As with if statements, the code inside the block should be indented. So it's really important to understand, if you're accustomed to using curly braces like I am to delineate blocks of code, you can almost pretend that these have the curly braces so that you know what's being ignored when specific if conditions are false. So with that being said, I'm going to double check, I'm going to pay better attention to the indentations. So anyway, here we have x equals 4. If x is equal to 5, well, that's not true. So we're going to ignore what belongs to that if x equals 5, which is the following indented statement, print yes. Now you have an else, which is not indented anymore. It's not straight under print. It's to the left more. And so therefore, it will run. Because x equals 5 is not true, the else will run. So print no is the result. What is the result of this code? If 1 plus 1 is equal to 2, colon, well, that is true, so we're going to drop down and we're going to... Travis Burke started following you. Hi, Travis. Okay, so since that part is true, we are going to go on inside and do the code that belongs, the indented code that belongs to the initial if 1 plus 1 equals 2. So if 2 times 2 is equal to 8, well, 2 times 2 is 4, so if 2 times 2 is equal to 8, that's false. So because that particular if condition is false, we are going to ignore the indented code that follows it. So we are not going to print if, we're going to go straight to the else, which is no longer indented. It is going to print else. So we are going to go with else being the output of the code. You can chain if and else statements to determine which option in a series of possibilities is true. For example, num equals 7. If num equals 5, false statement, so let's ignore the indented statement. Else is back out to the left again. If num is equal to 11, that's also false, so we're going to ignore print number is 11. But now we have else if num is equal to 7. This is true, so print number is 7 should be part of the output. And we should ignore the last else. Number isn't 5, 11, or 7. We should just get the output number is 7. And as you can look at the bottom where it says result, you actually do see that the result is number is 7. Fill in the blanks to compare the variables and output the corresponding text. X equals 10, y equals 20. We're going to make an if statement here, an if condition. So if x is greater than y, colon, print the string if statement, else, what happened? Else, print else statement. Oh, I messed something up. What'd I forget? Else, maybe another colon. Else, colon. There we go. If x is greater than y, colon, print if statement. Else, colon, print else statement. The elif, which is short for else if statement, is a shortcut to use when chaining if and else statements. A series of elif statements can have a final else block, which is called if none of the if or elif expressions is true. For example, num equals 7. If num equals 5, that's not true, so we're going to ignore the indented statement. Elif num equals 11, that's also not true, so we're going to ignore the indented statement for that. Elif num equals 7, this is true, so we are going to execute the indented statement after that, which is print the string number is 7, else print number isn't 5, 11, or 7. Well, we didn't even have to worry about the else. That's going to be ignored because we did find a true statement, and that is elif num equals 7. And as you can see, the result is the output. The string number is 7. In other programming languages, equivalents to the elif statements have varying names, including else if with 2 separate words, else if with 1 word smashed together, or else if spelled with only 1 E. So once you start learning a lot of different programming languages, you're going to see the subtle differences, and so remember that elif goes with Python 3. A shorter option for an else if statement is, let's see if I can spell it right, elif. Oh, not with a U, with an I. Elif. Boolean logic. Boolean logic is used to make more complicated conditions for if statements that rely on more than one condition. Python's Boolean operators are and, or, and not. The and operator takes 2 arguments and evaluates as true if and only if both of its arguments are true. Otherwise, it evaluates to false. For example, at the first insertion, we have 1 double equals 1 and 2 double equals 2. This statement will evaluate to true because both the left-hand side of the word and the right-hand side of the word and, both expressions on both sides of and, are true. Whereas in our next insertion, 1 double equals 1 and 2 double equals 3, well, 2 does not equal 3, so therefore our output is false. The third insertion says 1 not equal 1 and 2 equals 2. Well, 2 does equal 2 on the right-hand side of the and, but 1 not equal 1 on the left-hand side, that's a false statement. That's false. Therefore, the whole output is false. Lastly, the last fourth insertion, we have 2 less than 1. Well, that's false. And 3 greater than 6. That's false. So neither one of the sides of and is true. So we will evaluate to false for that statement as well. Python uses words for its Boolean operators, whereas most other languages use symbols, such as that double and symbol, the double pipes, and the exclamation point. What is the result of this code? If, in parentheses, 1 double equals 1, and, parentheses, 2 plus 2 greater than 3, well, let's evaluate what's on the left-hand side of the word and let's evaluate what's on the right-hand side of the and before we decide what we're going to ignore and what we're going to execute. On the left-hand side of and, we have 1 double equals 1. That is a true statement. 1 does equal 1. But when we're looking at the right-hand side of the and, we have 2 plus 2 greater than 3. 2 plus 2 is 4. Greater than 3. That is true. That is true. So we should see print the string true. All right, good. The or operator also takes 2 arguments. It evaluates to true if either or both of its arguments are true, and false if both arguments are false. So, unlike the and operator, or allows you to have the left-hand side or the right-hand side being true to evaluate to true. So at our first insertion point, we have 1 double equals 1 or 2 double equals 2. Well, both of those expressions are true, so our output is true. At the next insertion point, on the left-hand side of or, we have 1 double equals 1. That is true. Or, on the right-hand side, we have 2 double equals 3. Well, that part on the right is false because 2 does not equal 3. But we are using the or operator, so as long as one of the sides is true, the entire statement will evaluate to true. And then on the third insertion, we have 1 not equal to 1. Well, that's false. Or 2 double equals 2. That's true. So since one of the sides of the or is true, our statement will evaluate to true. At the last insertion point, we have 2 less than 1. Well, that's false. Or 3 greater than 6. That's also false. So because neither side of the or operator is true, we will have a final evaluation of false for this particular statement. Fill in the blanks to print the string welcome. Age equals 15. Money equals 500. If age is greater than 18, in which case age is 15. So that's a false statement. In order for us to allow this statement to be true so that we can print the string welcome, we don't want to use the and operator because age greater than 18 is false. We want to use the or operator because we want to be able to print welcome. And if we used and, both sides of and would have to be true. So if age greater than 18, which is false, or money greater than 100, which is true, we will get a true evaluation, so we will be able to print the string welcome. Unlike other operators we've seen so far, not only takes one argument and inverts it. The result of not true is false, and not false goes to true. So, at the first insertion, we have not 1 double equals 1. Well, 1 double equals 1 is a true example because 1 does equal 1, but because we put not in front of it, we get the output of false. On the second insertion, we have not 1 greater than 7. 1 greater than 7 is normally false, but because we put not in front of it, that false is inverted to true. You can chain multiple conditional statements in an if statement using the Boolean operators. What is the result of this code? If not true, which means it's asking if something is false, print the string 1. Elif not, parentheses 1 plus 1 double equals 3, then print the string 2. Else, print the string 3. So let's go over this a little slower. If not true, print 1. Well, how can I evaluate that very first thing to decide if I'm going to print 1 or not? Not entirely sure how to explain if not true, print 1, because I don't know what the default would be. If true, print 1. If not true, print, well, I'm going to go with a hint. Use 5 XP of your 93 XP to get a hint. I want a hint. Oh, they didn't give me a hint. They gave me the answer. Since I can't be sure if not true, if something is true or not true, I guess I can't print 1, but I'm sure that's not the explanation why we don't see 1. Elif not 1 plus 1 equals 3. 1 plus 1 is 2. 2 equals 3 is false, but because there's not in front of it, that's going to flip that output to true, which will allow us to print the string 2. So I do understand why 2's there. I just didn't really understand why we don't also print 1. Else, print 3. Well, since print 2 was established, and else is right below the if not, we will totally ignore that print 3. That's probably a horrible explanation, but that's what I got. Okay, great. Let's go to operator precedence. Operator precedence is a very important concept in programming. It is an extension of the mathematical idea of order of operations. For example, multiplication being performed before addition, etc. If you remember school, you might remember the acronym PEMDAS, which is parentheses, exponents, multiplication and division, multiplication, division, addition, and subtraction. That's the order precedence, the operator precedence, order of operations. The below code shows that double equals has a higher precedence than or. So not only do you have to memorize PEMDAS, you have to remember these special operators. So equals has a higher precedence than or. So at a first insertion, we have false, double equals, false, or true. Well, on the right-hand side of the equals, we have false or true, which means either side of the or operator can be used. So false equals false, or false equals true. That's going to evaluate to true because we have the option of using the false, and false double equals false is a true statement. All right. Double equals has a higher precedence than or. Okay, well, I guess I explained that wrong because since the double equals has a higher precedence than or, we are going to evaluate the left and right-hand side of the double equals first. And false double equals false is a true condition. And then we can evaluate what's on the left-hand side of or. On the left, false double equals false evaluates to true. So then you will have true or true. So you have the left-hand side of or being true and the right-hand side of or being true. So you get to evaluate that entire statement to true. The next insertion has the statement false double equals, and now we're using parentheses in which we have the statement false or true. So the parentheses groups false or true together, which the statement false on the left of or, true on the right of or, means that one side of the or operator is true. So false or true in parentheses evaluates to true. So therefore you therefore we have the statement now false double equals true. Well, that's not a true statement. False does not equal true. So that's why our middle statement evaluates to false. Okay, then we have our last our last statement. We have in parentheses false double equals false. So that's a true statement. So when you look at the parentheses here, you can just imagine the word true. So on the left-hand side of the or operator, you have true. And on the right-hand side of the or operator, you have true. So you got true on both sides. With the or operator, you only need to have true on the left or the right. In this case, we've got it on both. So of course, your statement is going to completely evaluate to true. Python's order of operations is the same as that of normal mathematics. And this is when I said PEMDAS, the acronym PEMDAS. Parentheses first, then exponentiation, then multiplication, division, and then addition, subtraction. What is the result of this code? But let me back up again. I just have to remember that the double equals has a higher precedence than than or. I just got to remember that part because that's new to me. What is the result of this code? All right, if 1 plus 1 times 3 double equals 6, we got to figure out where the precedence lies. Double equals takes precedence over or, but not over all the rest of the mathematical operations. And PEMDAS starts with parentheses. We have no parentheses. E is exponents. We have no exponents in this. M is multiplication. So we are going to see that 1 times 3. We're going to do that part of the statement first. So where you see 1 times 3, just imagine that is gone and it's just replaced with a 3. Then we don't have any division, but we do have A for addition. So we have on the left-hand side 1 plus, we already did the multiplication, which is 3. So now we have 1 plus 3 on the left-hand side of the double equals, which is 4. So now our expression has 4 on the left-hand side of the double equals. 4 double equals 6. Is that true? Why, no, it's not. So we're going to ignore the indented statement that says print yes. We are going to go to the else, which tells us to execute print the string no. Operator precedence. The following table lists all of Python's operators from highest precedence to lowest. So this is a good chart to keep for future reference, because if you don't use this very often, you will likely forget what has the highest precedence. So from highest precedence to lowest, we have the double asterisk, which is exponentiation, to raise a number to a certain power. Then we have, we've got this tilde plus minus. What that is that's the description of that is complement, unary plus, and minus. And these are method names for the last two are plus, at, and minus at. So I'm not entirely familiar. I'm just going to read through the table. The next operator shows the symbols for multiplication, division, modulo, and floor division. And as you can see, the description matches what the symbols, the operator symbols are: multiply, divide, modulo, and floor division. Again, on the next row, we have a plus and a minus, which stands for our addition and subtraction. Down to the next row, you see a double greater than symbol followed by a double less than symbol. And what those symbols refer to is right and left bitwise shift. The next row is an and symbol. The description of that and symbol is it is the bitwise and. The next row, we see a caret and a pipe symbol. And what those are is those are the bitwise exclusive OR and regular OR. So that caret is the bitwise exclusive OR, and the pipe symbol is the regular OR. Going down to the next row, we have less than equals, less than, greater than, and greater than equals symbols. Those are comparison operators. In the next row, we have you've got a less than and greater than symbol together. You have a double equals symbol together, and you have an exclamation point equal symbol. All of those are equality operators. The next row, we have, let's see, equals, modulo equals, division equals, floor division equals, minus equals, plus equals, multiplication equals, and exponentiation equals. All of those are assignment operators. Okay, we're almost done. In the next row, we have is, not. Those are identity operators. Next row, we have in and not in, which are membership operators. And finally, we have not, or, and those are logical operators. Okay, so that was definitely a mouthful. What is the result of this code? X equals 4, Y equals 2. All right, this is going to be fun. If not 1 plus 1 double equals Y. So let's evaluate that left-hand side of the that leftmost side of the expression, left of the or operator. If not 1 plus 1 equals Y. 1 plus 1 is 2, and Y, the value of Y is 2. So 1 plus 1 double equals Y is a true statement. So by putting not in front of that, we're asking if not 2 equals 2. Well, so that let's see. Let's see if I'm figuring this logic out correctly. That's making that left-hand side of the or symbol false, because 2 is equal to 2 naturally, but when you throw a not in front of it, you are taking a true statement and making it false. Okay, so the left-hand side of the or gets a false evaluation. So what's on the right-hand side of the or? Or x double equals 4. Well, x is created with a value of 4, so the expression x double equals 4 is true. So the left-hand side of the or is false, the right-hand side of the or is true, which means the whole left-hand side of the and is true, because when you're using or, you only need one side of the or to be true in order for the whole thing to evaluate to true. So the left-hand side of and is true, but the right-hand side of the and, 7 double equals 8, is false. And remember, with the operator and, you must have both the left and right-hand side of and true in order for that whole statement to evaluate to true. Now, let's see. As long as I didn't mess up my operator precedence, wow. The double equals takes precedence over or. I think I messed up my precedence. I have to go back and see what that double equals has precedence over. The double equals has precedence over the not operators, which means I have to look at this whole statement in a different way. Doggone it. Actually, I'm confusing myself. I'm just going to unlock this because I'm just going to unlock this instead of going back and forth questioning myself. Use 10 XP of your 93 XP to unlock the correct answer. Okay. I see correct, but I don't... Oh. The answer is no. Let's see if my initial evaluation would have given me no. If not 1 plus 1 equals y, 1 plus 1 does equal y, so not makes the left-hand side of the OR false. Or x equals 4, 4 does equals 4, so the right-hand side of the OR is true, which means that the entire OR is a true statement, because the right-hand side is true. So then we look at and, the left-hand side is true, the right-hand side is 7 equals 8, that part's not true, and has to have both the left-hand side of it true and the right-hand side in order for the entire thing to evaluate to true. So I got the first whole line of code evaluating to false, which means we are going to ignore the indented body of that if condition, which is print the string yes. We're going to ignore that. We're going to go right down to elif x greater than y. Else if, basically, if x is greater than y. Well, x is valued at 4 and y is valued at 2. That is a true statement. 4 is greater than 2. So print no should be the output, and as we can see, no actually was the output. I was overthinking it, and I thought maybe I was making a mistake with the operator precedence. The double equals comes before not, and so on and so forth. So I basically confused myself, which you can do. All right, now we are going to, wow, this is going to be a really long video. I have to go over while loops, lists, list operations, list functions, range, for loops, a simple calculator before I get to the Module 2 quiz. So this is a real long one. Let's go to the while loops and see if I can get through this quicker. An if statement is run once if its condition evaluates to true, and never if it evaluates to false. A while statement is similar, except that it can be run more than once. The statements inside it are repeatedly executed as long as the condition holds. Once it evaluates to false, the next section of the code is executed. So here we have a while loop containing a variable that counts up from 1 to 5, at which point the loop terminates. So we start off with I equals 1, while I is less than or equal to 5, colon. While this is true, the indented statements underneath will execute. So we will print the value of I, which initially is 1. So we're going to print, that's why when you look down at the result, the first line you see is a 1. After print I, after print parentheses I, we have the statement I equals I plus 1. So I starts off at 1, then we're going to add 1 to it, so then I is going to have a new value of 2. Then we're going to go back up to the while, because this is a while loop. We are going to ask, while 2 is less than or equal to 5. Well, that's a true statement, so we're going to print the value of I, which at this point is a 2. Then we're going to increment it. I equals 2 plus 1. Now I has a value of 3. We go back up to the while loop. I, which is 3 now, 3 less than or equal to 5. It's still a true statement, so we're going to print the value of it, which is 3. Then I equals 3 plus 1, which now I is going to have a value of 4. It's going to go back up to the while. I equals less than or equal to 5, which means while 4 is less than or equal to 5. Still true. Print I, which is 4, and then I equals 4 plus 1. So now I has the value of 5. Goes back up to the while loop. While 5 is less than or equal to 5. Still a true statement. So we're going to print the value of I, which is 5. Then we're going to say I equals 5 plus 1. So now I has the value of 6. Go back up to the while. While 6 is less than or equal to 5. Wrong. It's not true any longer, so now we jump out of the while loop. We ignore the 2 indented statements that belong to the while loop's body. We jump all the way down to the last statement that executes print the string finished. Therefore, when you look at the result, you see 1, 2, 3, 4, 5, finished. The code in the body of a while loop is executed repeatedly. This is called iteration. How many numbers does this code print? I equals 3. While I is greater than 0, print I equals I minus 1. So we start off with I having a value of 3. While 3 is greater than or equal to 0, that's a true statement. So we are going to execute print I. So we are going to print a 3. Then we are going to decrement I equals I minus 1. I equals 3 minus 1. So now I has a value of 2. Go back up to the while. While 2 is greater than or equal to 0, print I, which is 2. So the first number that printed was a 3. The second number that printed is a 2. Then we're going to decrement the 2. I equals 2 minus 1. So now I has a value of 1. While I is greater than or equal to 0, well, I is 1, so that's still a true statement. Print I, which is the value of 1. So now we've got 3 numbers so far, 3, 2, and 1. And then we're going to decrement I equals 1 minus 1, which is 0. So now I has the value of 0, while I is greater than or equal to 0, still true. So we've printed a 3, we've printed a 2, we've printed a 1, we're going to print a 0, and then we are going to decrement a 0. Well, I equals 0 minus 1. So now I has a value of negative 1. So when we go back up to the while loop, while negative 1 is greater than or equal to 0, false. We are now out of the loop. So the total, how many numbers does this code print? It prints a 3, it prints a 2, it prints a 1, and it prints a 0. 4 numbers will be printed with this loop. The infinite loop is a special kind of while loop. It never stops running. Its condition always remains true. An example of an infinite loop. We've got a while condition that never changes. While 1 double equals 1, print the string in the loop. And the reason it never ends is because we didn't increment it or decrement it. And so therefore the values never change. This program would indefinitely print the string in the loop, which is very annoying because it will freeze your screen. You can stop the program's execution by using the Control-C shortcut or by closing the program. Otherwise, you're going to see over and over and over millions and billions of times in the loop, in the loop, in the loop, in the loop. And it's just not something you ever want to happen. Fill in the blanks to create a loop that increments the value of x by 2 and prints the even values. So we start off with x set to a value of 0. So x is assigned the value of 0. We are going to do a while loop because that's what we're learning right now. While x is less than or equal to 20, we want to end this while loop condition with a colon, at which point we want to print whatever the value of x happens to be, and then we want to increment x by 2 because we want to print out just the even value. So x starts off at 0, and in order to count by 2's, you have to have x plus equals 2. X equals x plus 2. X equals 0 plus 2. X now equals 2. Then when you do it again, after we print the value of 2 out, then we're going to say x equals 2 plus 2. So now it's 4. And then x equals 4 plus 2, which is 6. So you see how you're going to go 0, 2, 4, 6, and so on and so forth, all the way up until x is less than or equal to 20. When x becomes 22, that while loop's condition will be false, and it'll jump out of the loop, and it won't keep printing values for x any longer. All right, to end a while loop prematurely, the break statement can be used. When encountered inside a loop, the break statement causes the loop to finish immediately. So here we have I equals 0, while 1 double equals 1, which, as you know, this is looking like an infinite loop because 1 is always going to be equal to 1. Print I means we're going to print the value of I, which initially starts with a value of 0. Then we're going to increment by 1 with the statement I equals I plus 1. So I equals 0 plus 1, so I equals 1. Then we have this if condition. If I is greater than or equal to 5, then you're going to print the string breaking. After which, you are going to use the break keyword, which is going to stop the while loop, which normally would have went on forever. And since you use break to jump out of the while loop, you get this final execution statement, print the string finished, which is not indented. So it does not belong to the while loop. It's outside of the body of the while loop, so it will execute. So our result is 0, 1, 2, 3, 4, the string breaking and the string finished. Using the break statement outside of a loop causes an error. So you see the while loop and where it's indented. Everything that's indented further inside, further to the right of the word while, that all belongs to the while loop. So if you were to take that break statement and put it way to the left and have it lined up with the very last print finish statement, then that break would not belong to the while loop. And using the break statement outside of the loop, it would cause an error, as this little note at the bottom is indicating. So you got to make sure you really understand how to indent and what statements belong to what conditions based on this indentation. All right, how many numbers does this code print? I equals 5. While true, now this statement is the same thing as saying while 1 double equals 1. While true means it's just going to go on forever. Because instead of giving you a condition to test for truth, you're just using the word true, so it means it's going to go forever. Now, after while true, we have all of these statements that belong to the while loop. Print I, which starts off as 5. Then I equals I minus 1, which is going to change the value of I from 5 to 4. Then an if condition, if I is less than or equal to 2, break. Well, 4 is not less than or equal to 2, so we ignore the break statement at this point and go back up to the while true, print I, which is now 4, and then we decrement it, I equals 4 minus 1, so now I has the value of 3. The if condition, if 3 is less than or equal to 2, well, that's still false, so we're still not going to break yet. Going to go back up to that while loop. We're going to print the value of I, which is 3. I equals 3 minus 1, so now I has a value of 2. Now when we ask the if condition, if 2 is less than or equal to 2, now that's a true statement. So now we get to utilize the break. How many numbers does this code print? Well, I went over how the logic works, but I didn't use my fingers to keep track of how many numbers that it prints. It's going to print 5. It's going to decrement. It's going to print 4. It's going to decrement. It's going to print 3. It's going to decrement to 2, at which point the if I is less than or equal to 2 will become a true statement, and it will break out of the while loop. So we're going to get a 5, a 4, a 3, but we are not going to print 2 because when we decrement and it becomes 2 and then it does the if condition which tests that 2 is equal to or less than 2, it breaks out, doesn't go back up to the while again. So we should have 3 numbers output with this while loop, and we do. All right, continue. Another statement that can be used within loops is continue. Unlike break, continue jumps back to the top of the loop rather than stopping it. So the break jumps out of the loop, continue goes back up to the loop. All right, so here let's go over this and let's let you look at the results if you want to while I'm reading the code. We start off with I having a value of 0. While true means this is going to run forever until we either continue or break. I is equal to I plus 1. So I started off as 0, but we're going to immediately increment it. That's the first thing we're going to do. So I is now going to have a value of 1. Then we have an if condition. If I double equals 2, that's not true right now, because right now I has a value of 1. So we're going to skip those two indentation statements and go to the next if. If I is equal to 5, well, it's not. It's only 1 right now. So we're going to also ignore the print breaking and the break statement, but we are going to print the value of I, which print I is not indented inside of the if I double equals 5, so it's not part of that if condition. So we're going to print I, which is 1. So when you look down to the result, the very first thing that you see is the number 1. Now we're going to go back up to the while loop again. Remember, I has a value of 1, but it increments I equals 1 plus 1. So now I equals 2. If I equals 2, if 2 equals 2, now it's a true statement. So now we're going to print the string skipping 2. And if you look down at the result, you see the line after 1, you see skipping 2. Then you see the continue keyword. What this does is, instead of going down to if I is equal to 5, it's going to go right up to while true again. It's going to go right up to the beginning of the while loop again. So I has the value of 2, but we're incrementing it. I equals 2 plus 1, so now I has the value of 3. So now when we ask if I is equal to 2, that's false, so we're going to ignore the two indented statements. We're going to ask if I is equal to 5, that's false, so we're going to ignore those next two indented statements. We're going to print the value, which is 3. Now we're still in the while loop. We're not printing finished yet, because notice print finished is not indented. It does not belong to the while loop. We're still doing the while loop. We're not done yet. So we go back up to the while. The last value that I had was 3. So while true, I equals 3 plus 1. Now I has a value of 4. If I is equal to 2, no, skip. If I is equal to 5, no, skip. Print I, which is 4. So if you look down at the result, you see 1, skipping 2, 3, 4. So far, you can follow the logic, right? So we printed 4, print I, we printed 4. I has a value of 4. We go back up to while true. Now we increment I yet again. I equals 4 plus 1. So now I has a value of 5. If I is equal to 2, wrong. So ignore the next two lines. They're indented. If I is equal to 5, it does now match, because 5 does equal 5. At this point, we're going to print the string breaking. Then we are going to obey the break, and that's going to break us out of the loop. So we are not going to print I. We are going to go straight to print finished, which is out of the loop completely. So therefore, our entire result was a number 1, skipping 2, 3, 4, breaking, and finished. Basically, the continue statement stops the current iteration and continues with the next one. Using the continue statement outside of a loop causes an error. So just like trying to use a break statement outside of a loop, you get an error. You try to do the same mess with a continue statement, it's the same way. The continue and break statement have to be inside of a loop, because that's their purpose. They're to either break an iteration or skip over an iteration. That's their purpose. Which statement ends the current iteration and continues with the next one? Well, that's pretty nice, because you got the hint right there in front of you. Continue. Okay, now let's look at lists. Lists are another type of object in Python. They are used to store an indexed list of items. A list is created using square brackets with commas separating items. The certain item in the list can be accessed by using its index in square brackets. For example, words equals, and in square brackets we have 3 strings. The string hello, comma, the string world, comma, the string and exclamation point. Then, when you go to the next line and you use the print command, print in parentheses the name of the list, which we assigned words, and then in square brackets, 0 means the index 0 of the list. Hello represents index 0. World represents index 1, and the exclamation point represents index 2. So what you wind up getting as a result is hello on the first line, world on the second line, and exclamation point on the third line. The first list item's index is 0 rather than 1 as might be expected. When you get used to programming languages, you pretty much know that when you're using indexes, index 0 is the first element or the first list item in a group of things. Alrighty, what is the result of this code? Nums, we have a list here. It's given a name of nums, and it is set equal to these values, which are held in square brackets. 5, 4, 3, 2, 1. 5 is a list item with an index of 0. 4 is a list item with an index of 1. 3 is an index with a list item, 3 is a list item with an index of 0, 1, 2. 2 has an index of 3, and 1 has an index of 4. Remember, 5 is the index of 0, so it goes index 0, index 1, index 2, index 3, index 4. So when we do the statement print nums index 1, we're going to get the output of 4. An empty list is created with an empty pair of square brackets. So on the left-hand side of the equal sign, which is the assignment operator, we have a variable called empty underscore list. On the right-hand side of the equals assignment, we just have an empty square bracket because it is an empty list. We haven't filled the list with anything yet. We just created an empty list. So therefore, when we use the statement print parentheses and then the name of the list, which is empty underscore list, your result is simply the square brackets with nothing inside because we didn't fill it with anything. Most of the time, a comma won't follow the last item in a list. However, it is perfectly valid to place one there, and it is encouraged in some cases. How many items are in this list? Okay. You have the square brackets, you have a 2, and a comma. I'm going to say there's only one item in there, which is 2. One item in that list. And I'm right. Typically, a list will contain items of a single item type, but it is also possible to include several different types. Lists can also be nested within other lists. So here's our examples for that. We have number equals 3. Then we have a list with a name called things. Things equals, and then everything that belongs to the list called things is enclosed in these square brackets. The first list item is the string data type string, the word string basically. After that we've got a comma, in which we're going to add our next list item, which is simply the number 0. Then we have a comma, and the third list item that we have for this list called things is actually another list. And this is a list with a number 1, a number 2, and just a variable called number, which we gave number a value of 3 in the very beginning. Okay, then there's a comma after that list item, set of list items, and we have a decimal or a float, 4.56. Now, when we get out of that entire list with the name of things, and we get down to the subsequent lines that use print to output stuff to the console, we have print parentheses, the name of the list, which is things, and in square brackets, the index. So index 1 isn't the first list item, it's actually the second, because lists start with index 0. the 0 item, the 1 item, the 2 item, the 3 item, and so on and so forth. So print things index 1 is going to give us the output of 0. So when you look down in result, you see the very first line of our output, it is in fact 0. Then when we get to the next print command, we have print parentheses things index 2. Now we're dealing with that list that has in square brackets 1, 2, number. Now remember, number is a variable which has a value of 3. So that's why when you see the output, the second line of output under result, you see the list and it has a number 1, number 2, and number 3 contained in the straight brackets. Lastly, we have print parentheses things, and this is interesting because we are still pointing to the things with an index of 2, but we are also looking at the second item of that. Things index 2 gives us another list, which is 1, 2, and number, which has a value of 3. But here we are pointing to that list, and then we are picking only the second item in that list. So when you look at the list 1, 2, number, which again has a value of 3, 1 would be the 0 index of that list. The 0 index would give us the value of 1. The first index of that list would give us a value of 2. The second index of that list would give us the value of number, which was given, assigned a value of 3 in the statement before, in the first statement. So what we should get, and we do, in our third line of the result is 3, which is the value of the variable called number. Okay, lists of lists, which this actually had a list contained inside the list, they're often used to represent 2D grids, as Python lacks the multi-dimensional arrays that would be used for this in other languages. Fill in the blanks to create a list and print its third element. So we have on the left-hand side of the assignment equals symbol, we have the name list. So we're going to create a list with a name list. So list equals, we have to contain our elements, our list items, our list elements. We have to contain them with square brackets. So I have to find the symbol for the opening square bracket. Okay, they gave us the elements 42, 55, and 67, and they also closed up the square brackets for us. Now we want to print the third element. The 0 element gives us the value of 42. The first element gives us the value of 55. The second element, actually, I think I'm saying it wrong. The third element, the first element is 42. The second element is 55. The third element is 67. But they are of index 0, 1, and 2, respectively. So the third element isn't going to be print list index 3. It's going to be print list index 2. Because, again, indices start with 0. Indexing out of the bounds of possible list values causes an index error. Some types, such as strings, can be indexed like lists. Indexing strings behaves as though you are indexing a list containing each character in the string. For other types, such as integers, indexing them isn't possible, and it causes a type error. So let's take a look at the example. Here we have a variable called str, which is short for string, and we are assigning it to the string, enclosed in double quotes, hello world, which also has a space in between. So we include the space as another indexed element in this list, just to let you know. So when we use print parentheses str index 6, let's start counting, starting with H. H is 0, index 0. E is 1, L is 2, L is 3, O is 4, space is 5, W is 6. So print string index 6 gives us the result of W, because don't forget, you have to count spaces as index positions. You can't just ignore them. Which line of code will cause an error? Okay, let's see if I remember. So we start off with a list with the name of num. Num equals, and then in square brackets we have all of the elements of the list. 5, 4, 3, another list with one item, because it's enclosed in square brackets and it only has one element in it, which is a 2, 1. So we have 5 list items that belong to the list num, and our first print command is print num index 0. That's going to output 5, and there should be no problem at all with that output, so we should have no error there. The next print command we have is print num index 3 index 0. What this means is, first we identify num index 3. Well, num index 0 is the 5, num index 1 is the 4, num index 2 is the 3, num index 3 is the 2 in square brackets. So we've identified that we're looking at what's in the square brackets at that location, but we also need to identify the 0 part. Well, since that 2 is all that's in that square bracket, that does have index 0. So the value for print num index 3 index 0, that is also legal. It will not cause an error. It's basically going to spit out the value of 2. Now print num index 5 is going to give us a problem, because our list called num has num index 0, num index 1, num index 2, num index 3, and num index 4, which is the final element, which is the number 1. So it only goes as high as num index 4. We don't have a num index 5. So therefore we will get an error for line 4. Line 4 will give us a boo-boo. The first line creates the list called num. The second is a print command, the third is a print command, and the fourth is the final print command, and that's what's going to give us a problem. All right, now let's look at list operations. The item at a certain index in a list can be reassigned. Okay, for example, we have a list called nums, and we are assigning it 7, 7, 7, 7. So this is nums index 0, nums index 1, nums index 2, nums index 3, nums index 4. Well, here on the next line, we have nums index 2 equals 5. Well, in nums index 0 is the first 7, nums index 1 is the second 7, nums index 2 is the third 7. So the third 7 is going to be changed to a value of 5. So when we do the print command, print nums, we are going to get 77577 is the result. What is the result of this code? Nums equals square brackets 1, 2, 3, 4, 5. Nums index 3 is going to be reassigned the value of nums index 1. So first let's figure out what nums index 3 is. 0, 1, 2, 3. The value for nums index 3 is the 4. And what's nums index 1? That's the 2. Okay, so nums index 1 is the 2. that value is going to be placed in nums index 3. So when we print nums index 3, we're going to now have the value of 2. We just changed its value. Lists can be added and multiplied in the same ways as strings. For example, nums equals square brackets 1, 2, 3. Now we're going to use our print command, and in parentheses we have nums, which is the 1, 2, 3 in square brackets, and we're using the plus symbol to add to that in its own square brackets 4, 5, 6. So you have 1, 2, 3, and we're going to add to it 4, 5, 6. So let's see. When we have print the value of nums times 3, okay, we have two different print outputs. The first one takes the original list of 1, 2, 3 and adds to it 4, 5, 6. So when you look down at the result, you get one list that houses 1, 2, 3, 4, 5, and 6. One list that houses all of those. Now when we get to the second print command, we have print, and in parentheses we have nums times 3. This second print command is not referring to the first print command. It's referring to the original value of nums, which is simply 1, 2, 3. But we are taking that list 1, 2, 3 and we are multiplying it 3 times. So you will have 1, 2, 3, 1, 2, 3, 1, 2, 3 when you have print nums times 3. So when you look at the result, the first output is 1, 2, 3, 4, 5, 6 in square brackets. The second output is 1, 2, 3, 1, 2, 3, 1, 2, 3 in square brackets. Lists and strings are similar in many ways. Strings can be thought of as lists of characters that can't be changed. Fill in the blanks to create a list, reassign its second element, and print the whole list. So let's start off with the first statement. Nums equals 33, 42, 56. It gave us the opening straight bracket, but it didn't give us the closing, so we need to find the symbol for the closing square bracket. Square bracket, straight bracket, you know what I mean. Now the second line of code, we have nums, and nums of what index are we going to reassign the value of 22? It wants us to reassign the second element. The first element is 33, but that's nums index 0. The second element is 42, and that's nums index 1. So that's what we want to put in our square brackets here. Nums index 1 equals 22. So now we have taken the 42 and we have replaced it with a 22, and we want to print the whole list. So we are going to use the print command, and in parentheses the name of the list, print nums. Now to check if an item is in a list, the in operator can be used. It returns true if the item occurs one or more times in the list and false if it doesn't. So we start off with a list that has the name of words, and words equals the string spam, the string egg, the string spam, and the string sausage in the list. So then we have the print command, print spam in words. All right, is the string spam in words? Well, it is. Spam is in there twice, as a matter of fact. So we're going to get the result of true because it does exist. The second print command, print the string egg in words. Well, spam, egg, spam, sausage, egg does reside in the list called words, so that's also going to give us a true output. Lastly, We have print the string tomato in words. Well, our words list does not include the string tomato at all. So we are going to get a false result, a false output for that particular print command. The in operator is also used to determine whether or not a string is a substring of another string. What is the result of this code? Nums equals 10, 9, 8, 7, 6, 5. So those are all of the list items in the list called nums. All right. Now we're going to reassign some values. We are going to change nums 0, which num 0 means the 10 in that list. And we are going to change it, instead of it being a 10, we are going to reassign it to nums 1 minus 5. Well, the value of nums index 1, that's the 9 that you see in the list. So 9 minus 5 is 4. So on the right-hand side of the equal symbol, that evaluates to 4, and we're going to take that 4 and shove that as the value for num 0. So 10 is now going to become a 4. So then we get to this if condition. If 4 in nums, well, we just took the 10 and turned it into a 4. So if 4 in nums, that's true. There is a 4 in nums. So we are going to execute the statement that is indented after if 4 in nums, which is print, parentheses, nums index 3. Nums index 3, what's the value for that? Well, nums index 0 is a 4, index 1 is a 9, index 2 is an 8, and index 3 is a 7. So since there is a 4 in nums, we are going to print out the value of nums index 3, which is 7. So let's just put that in there. Yay! To check if an item is not in a list, you can use the not operator in one of the following ways. So here we've got a list called nums, and the three things that are in the list is a 1, 2, 3. The first print command, print not 4 in nums. Okay. Pretend the not's there. If this were print 4 in nums, is there a 4 in nums? No, there's not. So that would be a false evaluation. But because we have the not keyword before that, that is now going to be a true evaluation. So the first print command is going to give us the word true, a true evaluation. The next print command, print, parentheses, 4 not in nums. Print 4 not in nums. If this was print 4 in nums, there is no 4 in nums, so it would evaluate to false. But since, again, we're using that not, it's going to flip the false result to true. So the evaluation output for the second print command is going to be true as well. Then we have the third print command that says print not 3 in nums. Again, let's first pretend that that old crazy not word is not there. Print 3 in nums. Well, there is a 3 in nums, so that would evaluate to true. So you would print the Boolean word true. But since we're using that crazy not, we are going to go from having a true evaluation to a false evaluation. We're going to print false. Lastly, we have the fourth print command, which is print, parentheses, 3 not in nums. Again, if not wasn't there at all, print 3 in nums. 3 is in there, so it would give us a true output. But since we're using not, we have to consider that to be false. So, moving on. Fill in the blanks to print yes if the list contains Z. Great. So we have a list called letters. And the elements in the list are the string A, comma the string B, comma the string Z. We want to ask if the string Z in letters, if this is true, which it is, we are going to execute any indented statements that belong to that if body. And so, therefore, we just wrote the code to print yes if the list contains the string Z, the character Z, actually. All right, we still got a long way to go before our quiz. List functions. Another way of altering lists is using the append method. This adds an item to the end of an existing list. So we start off with a list with the name of nums. Nums equals, in straight brackets, 1, 2, 3. The next command we have is nums.append parentheses 4. So now when we use the print command to print parentheses nums, you get the result of, in square brackets, 1, 2, 3, 4. We have appended a 4 to the end of the nums list. The dot before append is there because it is a method of the list class. Methods will be explained in a later lesson. What is the result of this code? Words equals the string hello, enclosed in straight brackets. So there's only one list item here for this list. All it's got is a string hello. Then we use the name of the list, which is words, a dot operator, and that keyword append. And in parentheses and double quotes, we are adding to it the string world. Then we get to the print command. Print parentheses words, which again is the name of the list. And in this time, we are going to choose an element from the words list. This is going to be choosing words with an index of 1. Well, hello had the index of 0. We appended another element to that list, which is world, which actually is words index 1. So world should be the answer that we're looking for, and it is. All right, to get the number of items in a list, you can use the len function, short for length. Nums equals, in square brackets, 1, 3, 5, 2, 4. We're going to use our print command, and in the parentheses, we use the keyword len, because we're going to check out the length, the number of items in the list, and then in parentheses, the name of the list, which is nums. This is going to give us a result of 5. It's not asking what is the highest index of the list. It wants to know how many items are in the list. We have 5 items, and so the result is 5. Unlike append, len is a normal function rather than a method. This means it is written before the list it is being called on without the dot. So we didn't have len.nums. We had print parenthesis len, parenthesis nums. What is the result of this code? Letters equals, and in square brackets we have the string A, comma the string B, comma the string C. Letters dot append the string D. So now the value of the list, basically the list called letters is going to have an A, a B, a C, and a D. It's going to append the D to the end of the list. So then we are going to use the print command to print something out. We are going to use the len command because it's going to count how many items are in this list. And then in the most internal parentheses, we have the name of the list, which is letters. Letters will have 4 items now because we tacked a D onto it. We appended a D to the original list that only had 3 items, so now it has 4. The insert method is similar to append. except that it allows you to insert a new item at any position in the list, as opposed to just the end. Append sticks it to the end. Insert sticks it where you want to stick it. So here we have the list called words, and it has the string Python and the string fun as two items in the list. Then we're going to take the variable index and give it a value of 1. After that, we're going to use the name of the list, which is words, the dot to insert a method, and this method happens to have the name of insert. And then in parentheses, we are going to put the variable index, which we gave a value of 1. So we're actually thinking of index 1 with a comma and a string is. So when we have the print command and we want to print the value of words, which is a list, our result is a new list that contains the first element, which was Python, which is at index 0. And since we replaced or we inserted the new element, which is the word is, we inserted that at index 1. So Python is index 0, index 1 is this new word is, and then the very last index 2 is fun, which the list originally had Python and fun. We just took is and inserted it where index 1 would belong, which is in the middle. What is the result of this code? Nums equals square brackets 9, 8, 7, 6, 5. Nums.append parentheses 4. So I'm going to stick a 4 at the end, so it's going to be 9, 8, 7, 6, 5, 4. Then I'm going to use nums.insert. At index 2, I'm going to put an 11. So now the new value of nums, 9 is index 0, 8 is index 1. We're going to stick this 11 after the 8 because that's going to be index 2. That's going to be where the position of index 2 is. So now my list is going to be 9, 8, 11, 7, 6, 5, 4. 9, 8, 11, 7, 6, 5, 4. 9, 8, 11, 7, 6, 5, 4. I'm getting 7 elements now, 7 items in that list. So when I use the last command, which is print, parentheses len, which means we're going to look for the length, we're going to look for the length of the list called nums. And I said it should have 7 elements in it, 7 items. All right, the index method finds the first occurrence of a list item and returns its index. If the item isn't in the list, it raises a value error. So our first line is we're creating a list. It's got the name of letters, and it contains a P, a Q, a R, an S, a P, and a U. Then we're going to use the print command with a parentheses, letters, dot index, parentheses, the string R. So we're looking for the first occurrence of R. P is index 0, Q is index 1, R is index 2. So when we look down to the result, our first line of the result is a 2 because that letter R resides at index 2, 0, 1, 2. Our next print command is going to say print parentheses letters dot index parentheses the string P. So the first P that it finds is at index 0. So if you go down to result, you see the second line shows a 0. The final print command is print parentheses letters dot index parentheses the string Z. Well, there is no Z in our letters list. So we get value error colon Z is not in list. There are a few more useful functions and methods for lists. Max parentheses list colon returns the list item with the maximum value. Min parentheses list colon returns the list item with a minimum value. List dot count parentheses obj colon returns a count of how many times an item occurs in a list. So that's good to know. List dot remove parentheses obj colon removes an object from a list. And list dot reverse empty parentheses colon reverses objects in a list. And the only way to get all these methods down is to just practice and use them all repeatedly in different ways so that you just get the feel for doing the code and learning the methods. All right, drag and drop from the options below to add the character Z to the end of the list and print the list's length. Well, they already gave us list and a dot, and we want to add Z to the end of the list, so I want to use the keyword append. List.append parentheses the string Z. That's the first thing that we did. Then we want to print the list's length. So we have print. The name of the list is list. No, I think that's wrong. Let me take that back off. We want the length of the list. So we want to print parentheses len parentheses list. There we go. Range. The range function creates a sequential list of the numbers. The range function creates a sequential list of numbers. The code below generates a list containing all of the integers up to 10. So we have the name of a list called numbers. We are using a single equal sign to assign it to list parentheses range parentheses 10. The next line of code is using the print command where we want to print numbers. We want to print the numbers list. Our result, since we are outputting the value of a list, we have square brackets that are going to show, and since we're using range to 10, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the range is 0 to 9. And if you count all of those list items, you have 10 items there. They just start at 0. That's why you don't have the number 10 included, because 0 adds another to the list. So you have 10 items in there, but it's 0 through 9. The call to list is necessary because range by itself creates a range object, and this must be converted to a list if you want to use it as one. So basically, using the word list makes sure that you're dealing with the data type of list. What is the result of this code? We are creating a list with the name of nums. Nums equals, we're using the keyword list because we want to make sure that our output is converted into a list object. So we have list parentheses range, because we're creating a range here, and we want to create this range up to 5. So you know that the value of nums is going to be 0, 1, 2, 3, and 4. Now when we have the print command, print parentheses nums index 4, nums index 1 would be the 0, index 2 would be 1, index 3 would be 2. Index 4 would be 3. I think I said that right. 0, 1, 2, 3. 3 should be the value. And I messed up. Let me back up. Back. All right. Print nums index 4. 0, 1, 2, 3, 4. That's giving us a list with 0, 1, 2, 3, and 4. 0, 1, 2, 3, 4. Okay, so nums 4 should be 4. Had to use my fingers to do the math. If range is called with one argument, it produces an object with the values from 0 to that argument. If it is called with 2 arguments, it produces values from the first to the second. So this is good to know. When you're using range, if you only have one number in parentheses after the keyword range, you know your range is going to be from 0 to something. Now with 2 arguments, you have 3 to 8. So numbers equals list parentheses range parentheses 3 comma 8. We are going to print the value of numbers, which gives us this result in square brackets of 3 comma 4 comma 5 comma 6 comma 7. So it starts with 3, but it does not include the 8. Just like if this were range 4, you would have it from 0, 0 to 4. Actually, 0, 1, 2, 3 would give us 4 elements. So again, when you see range 3 comma 8, your numbers are 3, 4, 5, 6, and 7. All right. The next print command, print parentheses range parentheses 20. That means that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Double equals, so now we're looking for equality. Range 0, comma 20 gives us the same thing. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Does not include that final, it's up to but not including the uppermost range indicator. So range parentheses 20 is equal to range parentheses 0 comma 20. What is the result of this code? Nums equals list parentheses range parentheses 5 comma 8. So the value of our list is going to be, we're going to have 5, we're going to have 6, we're going to have 7, and it's going to stop. It's not going to include the 8. It's going to have 5, 6, and 7. So then when we use the print command, print parentheses len, which is short for length, how many items are we dealing with in the nums list, we should get an output of 3 for the 5, for the 6, and for the 7. Good. Range can have a third argument, which determines the interval of the sequence produced. This third argument must be an integer. Numbers equals list parentheses range parentheses 5 comma 20 comma 2. So what we're going to get is a range. The list items are going to start with 5. They are going to stop at 19, but they are going to have an interval of 2. So we're going to get 5, we're going to get 7, we're going to get 9, we're going to get 11, 13, 15, 17, and 19. And we're going to stop. So print the value of numbers, as you can see, in square brackets, 5, 7, 9, 11, 13, 15, 17, and 19. Cool deal. What is the result of this code? nums equals list, parentheses, range, parentheses, 3, 15, 3. All right. So the value, the list items that are in this list called nums, it's going to start with 3. It's going to go from 3 to 14 in increments of 3. So we're going to get the 0 index is going to be 3. Index 1, nums with an index 1 is going to be 6. Nums with an index of 2 is going to be 9. So when we have the print command that says print parentheses nums index 2, our value should be 9. All right. Now we're almost, well, this is a pretty long video, but we're almost ready for our Module 2 quiz. Before that, we have for loops. Let's look at that. Sometimes you need to perform code on each item in a list. This is called iteration, and it can be accomplished with a while loop and a counter variable. For example, here we've got a list called words, and it's set equal to the items hello, world, spam, and eggs. 4 words are in this list called words. We have a variable called counter, and is set initially to a value of 0. We have another variable called max underscore index, and we are setting the value to len parentheses words minus 1. So if you just look at len parentheses words, the length of the words list is 4. There's 4 items in the words list. So the value of len words is 4. We are subtracting 1 from that, which is giving us 3. So 3 is what the value of max underscore index starts off as. Counter starts off as 0, and max index starts off as 3. Then we have a while loop. Let me move this down so you can look at the result while I talk about the code. We have a while loop that says while counter is less than or equal to max index. We have to make sure that that statement is true in order to execute all of the indented statements that are underneath the while loop. So the value of counter is 0. So while 0 is less than or equal to 3, because max index has a value of 3. So while 0 is less than or equal to 3, word equals words index counter, words index 0. Words index 0 is hello. The value of words index 0 is hello. So word has the value of hello. Then we use the print command to print the value of word plus an exclamation point. So when you look down to result, you see hello with an exclamation point. After we print word hello with an exclamation point, we take that counter, which is initially 0, and we bump it up to 1. Then we go back up to our while loop. While, this time counter has a value of 1, while 1 is less than or equal to 3, word equals words index counter. Counter is now 1. So words with an index of 1 is now pulling out the next element, the next list item, which is world. So the next line you're going to see printed is world with an exclamation point. And if you look down to result, you see it's world with an exclamation point. You then take counter and bump it up again. Now counter has a value of 2. While 2 is less than or equal to 3, word equals words index 2, which is now spam. So we're going to print spam plus an exclamation point, and then counter is going to be bumped up from a 2 to a 3. While 3 is less than or equal to 3, that's still a true statement because 3 is equal to 3. It can be either less than or equal to 3. Word is now equal to words index 3. Words index 3 is eggs. 0, 1, 2, 3. So now we're going to print eggs with an exclamation point. Then we're going to bump up our counter. Our counter is no longer going to be 3. It's going to be 4. While 4 is less than or equal to 3. That statement is no longer true, so we are not going to execute those indented commands. We're done. We're done. So the result is hello exclamation, world exclamation, spam exclamation, eggs exclamation. Done with the while loop. In the example above, it iterates through all of the items in the list. It accesses them using their indices, and it prints them with additional exclamation marks. It concatenates exclamation marks to each one of the items in the list. Which construct can be used to iterate through a list? Loops. For loop. Iterating through a list using a while loop requires quite a lot of code. So Python provides the for loop as a shortcut that accomplishes the same thing. The same code from the previous example can be written with a for loop as follows. So here we create our list called words, and we set it to all these different list items that we want, the elements, hello, world, spam, and eggs. And then we use our for loop like this. For word in words. Words is the name of the list. Word is just another variable. We could say for x in words. Then we would have print x plus exclamation point. So we're just using another variable. For word in words, print the value of word plus an exclamation. Here we get the same result. Hello exclamation, world exclamation, spam exclamation, and eggs exclamation. The best way to get in touch with being familiar with loops is to just code yourself to death. Use colors, use names of people, use foods that you like, something that you can assimilate to, and use your for loops and use your while loops just to get used to the syntax. The for loop in Python is like the for each loop in other languages. Fill in the blanks to create a valid for loop. First, we create a list with the name of letters, and we give it 3 elements, A, B, and C. We are going to say for L in letters, and we have the colon, print L. The for loop is commonly used to repeat some code a certain number of times. This is done by combining for loops with range objects. So we have for I in range, parentheses 5, colon, print the string hello. So here you see hello, 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 hello. That simple little for loop using a range lets you take the simple print command and do it 5 times without having to write print hello, print hello, print hello, print hello, print hello. You don't need to call list on the range object when it is used in a for loop because it isn't being indexed, so a list isn't required. Fill in the blanks to create a for loop that prints only the even values in the range. So here's our for loop. For I in range, and now we have that third parameter. The range is going to be from 0 to 20, but not including 20. So it's actually going to be from 0 to 19. And the steps that you want to take are even. So we want that to be 2. So print I, the value of I. So you're going to have 0, then you're going to have 2, 4, 6, 8, 10, 12, 14, 16, and 18. Since 20 is not included, you won't, after 18, you're done printing the value of I. A simple calculator. This lesson is about an example Python project, a simple calculator. Yay, I've reached level 3. Each part explains a different section of the program. The first section is the overall menu. This keeps on accepting user input until the user enters quit, the string quit. So a while loop is used. All right, this is getting kind of nifty. While true. Remember, when you have a while loop that says while true, this is creating an infinite loop that will go on forever until we have a break statement. So while true, colon, print the string options. And then print the string enter add to add two numbers. Then we have print the string enter subtract to subtract two numbers. Next we have the print the string enter multiply to multiply two numbers. Next print enter divide to divide two numbers. Next we have print enter quit to end the program. So we printed out all of these directions for the user. Then we have a variable called user underscore input equals input parentheses the string a colon and a space. Now we have an if condition. An if, elif, and else. If user input is equal to the string quit with a if the user inputs, if the user types quit, then user input equals the string quit will be true. And if it's true, it's going to use the indented code underneath it, which is a break statement, which means it's not going to do anything. It's going to break out of all of this. It's going to break out of the while loop, and you're going to be done with the operation. Elif, user input equals the string add. So if the user types in the string add, then here you have ellipses, which basically code that will apply to the fact that the user is wanting to add. Elif, user underscore input equals the string subtract, colon. Again, they have the ellipses here to indicate where you would put the code if the user wants to do a subtraction. Elif, user input equals multiply, colon, ellipses. Again, this is letting you know where the code would go. Elif, user underscore input equals divide, colon, ellipses, which is where the code would go. Else, if all of those if conditions and elif conditions are not true, then you're going to print the string unknown input. The code above is the starting point for our program. Okay, it accepts user input and compares it to the options in the if, elif statements. The break statement is used to stop the while loop in case the user inputs quit. If we were to replace the break statement in the code with a continue, what would happen? All right, let's look back. All right, so here, if instead of if user input equals quit break to break out of the while loop, if it was continue, then we would have no way to break out of the while loop. We would run the program forever. Okay, that's it would run forever. You would have to enter quit twice to exit. No, it would run forever. You need to have a reason. You need to have a break. You need to have a reason to break out of that loop. Okay, the next part of the program is getting the numbers that the user wants to do something with. So the code below shows this for the addition section of the calculator. Similar code would have to be written for all the other sections, the multiplication, the subtraction, the division, so on and so forth. So elif user underscore input equals the string add, colon. If they typed in the word add, then these two indented statements would execute. Num1 equals float, parentheses input, parentheses the string, enter a number. So you're going to, if the user types in the word add, the next thing that's going to pop up on the console is the statement enter a number, at which point the user types in a number, but because they are typing input, the data type for that number is going to actually be a string data type, which is why we have float on the outside of that to do a conversion, to take whatever they typed in and change that data type to a float, because we want to do some math. So we want to make sure that the data types that we're working with are mathematical data types. And a string is not a mathematical data type. A string is what you'd use for like words, not math. And so the value of that first thing that they type in is going to be converted to a float, and then it's going to be set as the value to the variable called num1. Then we're going to do the exact same thing again, but we're going to call the second variable num2. Again, they're going to see a statement that says enter another number, at which point they're going to type in another number because it's going to be an input statement, and whatever they type in initially is going to be a string data type, but we need to convert it to a float. This, using float, allows them to enter a decimal number. So when the user inputs add, the program prompts to enter two numbers and stores them in the corresponding variables. As it is, this code crashes if the user enters a non-numeric input when prompted to enter a number. So if they're telling you enter a number and you type in SOS to be a little bit of an ass, you're going to have your code crash because you can't change SOS. You can't convert SOS into a float data type. You can't do it. We'll be looking at fixing problems like this in a later module. Why are the calls to float necessary in the code? To convert user input to a float, to remove spaces from user input, or to check if user input is a number. It's a conversion. We're calling to float as a conversion, to convert from string data type to a float. All right, the final part of the program processes the user input and displays it. So the code for the addition part is shown here. So some of this is going to be repeat, and then we're going to tack on the additional code. So elif user underscore input equals the string add. So if the value of user input is add, they typed in add, then we are going to enter a number, which they are going to type in, and it's going to be converted to a float, which is a decimal value, and then it's going to, whatever that is going to be put into the variable num1. We're going to do the same thing for num2. Num2 equals float, parentheses input, parentheses the string, enter another number. Here's the new part. Result equals str, parentheses num1 plus num2. So whatever they put in that was given the variable num1, that value added to the second thing that they typed in is a float, because we converted it to a float. But because we want to print the output to them, we have let's see, we have str to convert it back to a string. So result equals str parentheses num1 plus num2, print parentheses the string the answer is, including a space, plus the variable result, and you're going to get the value of result. It's not going to print out the answer is result. No, the answer is whatever num1 plus num2 was. We now have a working program that prompts for user input and then calculates and prints the sum of the input. Similar code would have to be written for the other branches, for subtraction, for multiplication, and for division. The output line could be put outside the if statements to omit repetition of code. So the output line could be put outside of the if statements to omit repetition of code. They're talking about print the answer is plus result. Instead of putting print the answer is plus result in each and every elif, you can put it outside of the if statements. Outside of the if, elif, so that you only have one print the answer is plus result. Fill in the blanks to make the calculator work for multiplication. Well, they've given us quite a bit of the code, so I'm just going to read it from top to bottom and fill in the blanks as needed. Elif user underscore input equals the string multiply, colon, num1 equals float, parentheses input, parentheses the string, enter a number. Next, num2 equals, we're going to follow our leader, we're going to use float, parenthesis input, parenthesis the string, enter another number, colon. And then you close up the inner and outer parentheses for both of those lines. I just didn't read that. The third line of code is result equals str, because now we're converting our float to a string again. Num1, now we're multiplying, so we don't want to use the plus symbol, we want to use the asterisk. Num1 times num2. And then finally, we use the print command to print out to the console the string. The answer is plus the value for the variable called result. Oh, yay! We're now at Module 2 quiz. What is the output of this code? So we have a list, named list, and all of the elements in it are 1, 1, 2, 3, 5, 8, 13. So there's 1, 2, 3, 4, 5, 6, 7 items in this list. We are going to print. All right, so, how can we do this? We have things nested here, and it's usually a good idea to find the innermost nest, figure out what the value of that is, and then branch out bit by bit to understand what the output's going to be. So let's look at the innermost section of this print parenthesis list square brackets list square brackets 4. Let's see. List index 4. List index 0 would be the first one. List index 1 would be the second one. List index 2 would be the 2. List index 3 would be the 3. List index 4 would be the 5. So list index 4 is a 5, okay? The value of the innermost list index 4 is a 5. So just pretend in your mind that list index 4 is gone, and a number 5 replaces it in the outermost square brackets. Now we're bubbling out. Print, parentheses, list, index 5. List index 5 now is, if you go to 1 being 0, second one is 1, 2 is 3, 0, 1, 2, 3, 4, 5. List index 5 is actually the value of 8. It's the number 8. So print list index 5 will give us an output value of 8. What does this code do? For I in range parentheses 10, what is range parentheses 10? It is 0 through 10, not including 10. So it is 0 through 9. Okay, so get that in your mind. 0 through 9. Next, we have an if condition. And let's pretend the not is not there. And let's figure out what it is truthfully before we use not to invert whether true becomes false or false becomes true. So let's pretend not's not there. If I modulo 2 equals 0, what this is asking you is if I divided by 2 gives you the remainder of 0, then you would print I plus 1. Now, I starts off as 0. 0 divided by 2, 0 divided by 2, let's see, 0 divided by 2 is going to be 0. 2 goes into 0 0 times. So 0 would be the first list item. And it's true. 0 divided by 2 does give you a remainder of 0. So if that were true, you would print 0 plus 1. But we have not going in front of it, which means we are not going to print. We are basically going to call that false. 0 divided by 2 equals 0 is a true statement, but we precede this with not, which means it's going to be false. So if a condition is false, you ignore the indented material underneath it. So we are not going to print I plus 1. We are not going to print 0 plus 1. We go back up to the for loop, which goes to the next element, which would be a 1. Okay? If 1 divided by 2 gives you a remainder of 0, well, 2 goes into 1. You have to use decimal here. 0.5. Wait. 1 divided by 2 is 0.5. It's 1/2. There's a remainder there. So, therefore, the modulo is not 0. It's false, but because not's in front of it, it's going to flip that false to true. So now we are going to print. So we are going to print 1 plus 1. We didn't print 0 plus 1. We are going to print 1 plus 1. So 2. So what we should have is we should, I hope we should have print all the even numbers between 2 and 10. Wait a minute. Yeah, because our print is not to print the value of I, it's to print the value of I plus 1. 0 we didn't print. We went back up into the loop, and the next list item after 0 was 1. Well, we're not printing 1, we're printing 1 plus 1. So it should be between 2 and 10. Between is the key here. Between 2 and 10 is not including 10. It does include 2, but it doesn't include 10. Yay, team. All right, how many lines will this code print? While false, print the string looping, ... Well, when you're looking at conditions, the only reason you ever execute a statement underneath a condition is if the condition is true. So while false means you're never going to print anything. So you will print nothing. How many lines will this code print? 0. Fill in the blanks to print the first element of the list if it contains even number of elements. Okay, we start off with a list. It has the name of list, and the elements that belong to it are 1, 2, 3, and 4. We want to have the condition being that it contains even number of elements. So we're counting elements here. So we want to use that special len for length. If len list modulo 2 is equal to 0, that is saying that, okay, there's 4 elements, 1, 2, 3, and 4. So if you just wanted to know what is len list is going to give you a value of 4 because you've got 4 elements there. So the value of len list is 4. Modulo is the percent sign, so 4 percent sign 2 equals 0. That's the condition. 4 divided by 2, 2 goes into 4 evenly with no remainder. Because we're using the modulo symbol, that we only care about the remainder. The remainder happens to be 0. So len list modulo 2 equals 0 is a true statement because there are 4 elements in this particular list. So if len parentheses list modulo 2 equals 0, now that's our condition. We want to end our condition with a colon. If that's true, which it is, we are going to execute the indented statement underneath the if condition, which is print parentheses list, and we want to print the first element of the list. The first element is number 1, which is list index 0. What is this code output? All right, so we've got a list. It's got a name of letters, and the elements in the list are X, Y, and Z. We use the name of the list letters with dot insert to do this function. We are going to insert at position 1, which is the index 1, we are going to insert the letter W. Well, in the initial letters list, X is letters index 0. So after letters index 0 will be letters index 1. So after the X, we want to put in the W. So X is 0, W is 1, Y is 2. And as you can see in the print command, we have print letters index 2, which is going to be the Y. X is the 0, W is the 1, Y is the 2. That's the value of letters index 2. Fill in the blanks to iterate over the list using a for loop and print its values. So we create a list. It's got a name of list. It's set equal. It's assigned 3 elements, 1, 2, and 3 in square brackets. We want to iterate over the list using a for loop. So we want to use the keyword for var in list. Var is short for variable. You could say for X in list, for item in list, for balloon in list, whatever. In this case, they're just using something called var. So for var in list, colon, print var. Print the variable, print the element, print the item. All right, so that completed the very long video for control structures. The next video will go over Python 3 functions and modules. I can't find my this.